Okay, so guys, in this video we have to find the implicit differentiation twice of this function given to us. So first of all, let's just apply the differential on all of these terms so that we can find dy by dx, and after that we will again apply the differential to find d square by dx square, which will actually be the successive differentiation of this function. So let's begin. First of all, d by dx x square, d by dx y square. Now c is actually a constant, f is a constant, g is a constant, and everything else is a variable. What is else? Of course it is x and y. So c, f and g are constant. So first of all, the derivative of c would be 0 because the derivative of any constant is 0. Actually, we should also apply the differential over here with a 0 so that the equation balances, because we will apply the differential on both sides of the equation. So 2f is a constant, let's just separate it, and then we are left with d by, this is remaining, so y. Then we have plus 2gx, so 2g will be separated and we are left with d by dx x. Okay, so this will be remaining plus over here. So the derivative of x squared would be 2x because the power will be separated than the function as it is, plus the derivative of 2y would be 2y multiplied by the derivative of the function. What is the function? dy by dx. This will be cancelled and we are left with 2g multiplied by 1 plus 2f. This cannot be cancelled, so we are left with dy by dx is equal to 0. Okay, so this is the thing which we want to separate in order to find dy by dx. We are actually having dy by dx in two of these terms. First of all, we have dy by dx in this term right over here, 2y dy by dx, and then we have 2f dy by dx. Okay, so let's just separate both of these terms and we will move the unlike terms towards the opposite side of the equation, i.e. 2g and 2x will move towards the right hand side of the equation. Negative 2g, negative 2f, because we will of course separate 2g on both sides and 2x on both sides. Actually it is 2x. So we will have negative 2g and negative 2x because over here we are having them in positive. Over here we have 2y dy by dx plus 2f dy by dx. Okay, so let's just take out dy by dx common because it is present on both of these terms. So we have 2y plus 2f is equal to negative 2g negative 2x. Let's just divide this term, 2y plus 2f. So we have dy by dx. Let's just take out this 2 common. So we have negative g negative x, and over here we can also take out the 2 common. So we have 2y plus f. So the 2's will be cancelled and we are left with negative g negative x divided by y plus f. Okay, so this is y1, okay, the first derivative. Now we will find the second derivative. Okay, let's begin. y2 would be equal to d square y dx square. So this is my fx and this is my gx. So we can actually use the division theorem for finding the derivative of this function. So this is the division theorem and let's just use it. So this is my fx, the first function, and this is my gx, the second function. Okay, the second function as it is, y plus f, derivative of the first function, d by dx. What is the first function? It is negative g negative x minus the first function as it is, derivative of the second function, that is y plus f, divided by square of the second function. Now over here g and f are constants, so the derivative of them will be 0. The derivative of g and the derivative of f will be 0 because the derivative of any constant is 0. So the derivative of negative x will be negative 1 and the derivative of y will be dy by dx. So let's just write these terms on the next page. So the derivative of negative x was negative 1 and the derivative of y was dy by dx. G and f were constants, so the derivative of them was 0. So let's just multiply this negative sign with these terms present right over here. So we have negative y negative f. Over here we have negative g minus x. Now remember, I'm not going to multiply this negative sign because we have to put the value of dy by dx. Okay, so what was the value of dy by dx? It was negative g negative x divided by y plus f. So we can just, take the LCM right over here. So we have y plus f, and over here we have the actual denominator. So if we multiply y plus f with this term right over here, because we are having 1 by default, so we will have negative y negative f y plus f. The y plus f, the denominator, the LCM, will be multiplied by the numerator of this function because the 1 cannot be taken out. Okay, negative g negative x, and over here the same terms present in the numerator will be as it is. So we have, okay, so a couple of things going on over here. First of all, let's just move this y plus f, the LCM, to the denominator because we know x divided by a divided by m, and this is my a, so we can just move it towards the denominator. So we will have xa multiplied by m. So this is my a right over here and this is my m, so we can write x divided by a multiply m. So we have negative y negative f divided by y plus f whole square and y plus f. Okay, now let's just multiply these terms present over here. So we have negative y multiplied by y gives us negative y square, negative y multiplied by f gives us negative yf, y multiplied f gives us again negative fy, and f squared. So we have negative f squared. You know, these terms are actually same, so we can use the whole square formula over here. So we will have negative g whole square negative 2 negative g negative x plus negative x. Now the a minus b whole square formula actually says a square minus 2ab plus b square. Now concentrate on the variables over here. A is in positive format, right? And b is in the negative format. So we were having a square minus 2ab. Over here we have negative g negative x. We have the both variables with the negative sign. So instead of having negative right over here, we will have a positive. So the a plus b whole square formula will be used over here. A square plus 2ab plus b square. That formula will actually be applied over here because the variables actually do not match with this formula. Now if you focus over here, if you focus on this formula, the b is in the positive format and the a is again in the negative format, because if we are not having any sign with any variable or any number, by default it's positive sign, right? So we have positive a, positive b. The signs are matching, so we can use this formula, okay? So over here we have negative and then again negative. So we have to match the signs for this middle term right over here. So we will use the a plus b whole square formula. I hope you get the point. Divide by y plus f whole square multiplied by y plus f gives us y plus f cube, because when the bases are same, the powers are added. 2 plus 1 gives us 3. So we have negative y square negative f, let's just write it 2fy, because negative fy gives us negative 2fy. These will be added but the signs will remain the same. Minus f square minus, okay, negative gives us positive, and the positive sign we have 2gx plus x square divided by y plus f cube. If we just take out these negative signs common, so we have negative sign common and we are left with y square plus 2fy plus f square, okay, plus this term will be as it is, g square plus 2gx plus x square. Now we can see that the formulas can again be closed, so we can write negative y plus f whole square plus g plus x whole square. And if you were shocked at what happened over here, so I have simply closed the formulas. We were having them in the open form. Y and f were my a and b's, g and x were my a and b's. So I just closed the formula a plus b whole square, a square plus 2ab plus b square. So if you see, if we have y over here, y plus f, okay, so if we just reopen them, we will have y square, a square plus 2ab, so 2 as it is, f and y, yf plus b square, so that is f square. Okay, so you see we have the same term which we were having in the previous step.